Today we're going to look at systems of linear inequalities. This should be mostly review. You've done this for a long time. First, let's look at Hoy and Vux. Vertical lines, Vux, V, UX. This is a, oh, I need a different color pen. Sorry. Vux means vertical line, undefined slope, x equals. So x is greater than -2. That is a vertical line. The y is less than or equal to 3. That is a Hoy. H for horizontal, 0 slope, y equals. So the y is less than or equal to 3. On the y-axis, find 3. And we need to put a horizontal line there. The problem is we need to know if that should be a dashed line or a solid line.
It's a solid line.
Why is it a solid line?
The line under the alligator thingy.
Okay. If it's like this, you use a solid line because that symbol is less than or equal to. And because it's or equal to, the line is included in the shading, so it is a solid shaded in line. For the shading, our y is the shaded stuff. The shaded stuff needs to be smaller than 3. Notice the alligator is eating the 3, so 3 is bigger. The shaded stuff needs to be smaller. Where on this graph are the y values smaller than 3? 2, 1, 0, down here. And I'm going to try to do this really light. It'd be shaded this way. Graphing systems of inequalities is kind of like writing a paper in English. We should technically have a rough draft and a final draft. I'm just not going to make you do a final draft, so I'll tell you what you need to do to make your draft more final. All right, the Vux. X is greater than -2. This is a vertical line at -2. Should this one be solid or dashed?
It is dashed.
Because it does not have the equal line. So it's just plain greater than, not or equal to. So the line is not included as with the shading. The line is a boundary showing you where the shading will end. The shaded stuff x has to be bigger than -2. So where on this graph are the x values bigger? -1, 0, 1 over here. Okay. Your final solution area is the place where this is double shaded. I should make you regraph both of these and then put your final solution area. Instead, if you shade really, really lightly and then shade your final solution area nice and dark, that will suffice. So make sure that the lower right portion of your graph is shaded so that it's obviously the solution area. Make the rest of your shading super light. Or take an eraser and erase out the other shading so that your final solution area is the most prominent. If you're watching the video, pause the video, try be on your own. Try be on your own, class. Once you graph both of these, the double shaded area is in between the solid and dashed line. So make sure that that shading is super obvious. It may be necessary to go back with an eraser and erase the other areas so that your final solution is very obvious. Okay. In example 2, the problem here is that we're going to have to rearrange these equations before we graph them. So in example 2a, this first equation, we would need to subtract 2x on both sides. When we subtract 2x on both sides, notice we are left with -y is less than or equal to -2x plus 5. How do we get rid of that negative? We have to divide by a -1. When we divide by a -1, what happens with the inequality symbol? It flips. So we have y is greater than or equal to positive 2x minus 5. So we are starting at negative 5. Remember, that is your y-intercept. You're beginning on the y-axis. The axes are even labeled on this example. Your slope is 2, so up 2 over 1. I know some of you are going to have to guess on your notes because the lines on your notes are kind of super light. This is going to be a solid line. The issue when you have a slanted line is how do you shade? You could pick 0, 0 and plug 0, 0 in and test a point to see if it works or not. I prefer to think of what this symbol actually means. Why is my shaded stuff? My shaded stuff needs to be bigger than the line 2x minus 5. So I always focus on my y-intercept. My y-intercept is negative 5. Where on the graph do I have y values bigger than negative 5? Negative 4, negative 3, negative 2. So I would like to shade on this side of the graph. For my other equation, we need to subtract x on both sides. I think I'll take this one up here. X plus 3y is greater than 15. Subtract x on both sides, and then divide by 3. So we have y is greater than, what is negative x over 3? What number is in front of that x?
1.
A negative 1. That is a negative 1/3 x plus 5. So we start at 5 on the y-axis. A slope of negative 1/3 means down 1, right 3. Remember that you only use the negative once. This one's a dashed line. For shading, I look at my y-intercept of 5. It says y is greater than 5 than this line, so my y values are greater up here. I would need to shade this part of the line. So this graph is double shaded in this upper left area. Make sure that part is super dark. My eraser is actually pretty cool because it erases all of that in one fell swoop to give us our final solution. Okay, if you're doing this on your own, try B on your own. Pause the video. In B, we have 2 dashed lines that are parallel. The purple one, it wants us to shade up. It wants us to shade where the y values are greater. The blue one, it wants us to shade where the y values are smaller. Do those shadings overlap at all? No. So because the shadings don't overlap, there are no solutions. If you have no overlapping shading, there are no solutions. Okay, let's take a moment on this first inequality to rearrange it. We would start by subtracting x on both sides, and notice that would give us negative y is less than negative x plus 2. When we divide by negative 1, we end up with y is greater than positive x minus 2. If you're watching the video, pause the video, graph that inequality, the vertical line and the horizontal line, and then we'll see where the shading overlaps. The actual solution area would be this horizontal line portion the dashed line portion and this dashed line portion and the triangle in between those. So if you've shaded everything super light, you should be able to darken that area. I'm lucky with the type of eraser I have. There is our final solution area. Now I'm going to put a couple of points on the graph and ask you if these are solutions or not. Is point A a solution to the system? No. Is point, well, let's go easy. Is point B a solution to the system? Yeah, it's definitely in that solution area. How about point C? Yes, it's on a solid line on the boundary of the solution area, so it is. But what if I were to put point D on that purple dashed line? No, because it's on a dashed line and the dashed line is not included in the shading. Okay, so the only 2 points here that are solutions would be B and C. Right? In your assignment, we're going to cross off number 47 for now. Your assignment is these pages. I think it's actually only page 426 through 428. 2, 6, 8, 10, 13, 14, 22, and 26.